Maths questions. Dear Maths Explainer, I had a few questions while practicing, so could you please help me? I'd be extremely grateful. The questions are below. P.S. I also watched your latest video. You said you love getting questions in your inbox. Thank you for watching, Hamna, and you're absolutely correct. I love hearing from you guys, whether it's an email or comments or whatever. Okay, so let's have a look at the questions then. We have 3 questions here. The first one says the price of all rail tickets increased by 5%. The price of a rail ticket from London to Ipswich increased by £2.30. Work out the price of the ticket before the increase. So it's really important here to realize when it says rail tickets increased by 5%, that's 5% of the original price. So let's go ahead and write that down. 5% of the original price. Original price. And that increase for the ticket from London to Ipswich is equal to £2.30. Okay? Once you have this equation, there's only a couple more steps to get to the final answer. So once we know 5% is equal to £2.30, then what do we need to do to get to the original price? Well, if we know 5%, we just need to think about what we need to multiply to get to 100%. For this, I would probably multiply by 2 to get 10%. So multiply both sides by 2. That's £4.60. And then multiply by 10. Okay? That's a pretty straightforward method, right? You could multiply by 20 in one go, but taking a couple steps is absolutely fine. So then we get 4.6 multiplied by 10, which is £46. That's your final answer. Now, there can be some confusion about wanting to multiply by 1.05, for example. So this would give you a 5% increase. Like, there are a lot of questions where you do want to multiply by 1.05 to increase something by 5%. But you don't need to do that here. It's adding an extra step that you don't need to have. So, for example, if we multiplied the original price, let's call it X. That's the original price. So if we multiply by 1.05, that's not going to equal £2.30. That's going to be the original price plus £2.30, right? Because this is just the increase, okay? Multiplying the original price by 1.05 would give you the price plus £2.30. So you're adding an extra step if you do it this way that you just don't need. Because if you, for example, take X from both sides here, you get what we ended up here. Okay? What we ended up with here. You could do it this way. You just need to realize that, you can't say this. This is not correct, okay? Because this is just the increase. This is the price increase, not the total final price. Okay, hopefully that made sense. On to the next one. It says, given that x plus a all squared multiplied by x take 2 is equal to x cubed plus bx squared plus 12x take 72, find a and b. Okay, this question is just asking you to expand these brackets over here. So that's the first step you need to do. And that's a little bit tricky because it doesn't say expand these brackets. But when you see questions like this where they're asking you to compare unknowns on both sides of an equation, generally what you want to do is expand the brackets first. So that's what we're going to do. So let's expand the x plus a squared. This is x squared plus 2ax plus a squared. You can also do, use FOIL and do it that way. Expand it out that way, so you'll eventually get to this. And then you need to multiply everything in the first set of brackets by everything in the second set. So x squared times x cubed, 2ax plus multiplied by x, 2ax squared. A squared times x is a squared x. Then x squared times negative 2, negative 2x squared, negative 4ax, and negative 2a squared. Okay, next, combine like terms. So there's only one x cubed, then we have a plus 2ax squared and a negative 2x squared. Then when I say combine, I just mean write them next to each other because we can't really actually combine them. Then we have a plus a squared x and a negative 4ax, and then we have a 2a squared on the end without any x's in it. Okay, next I would underline each term, each set of terms. So the x squared terms I'm going to highlight with orange, the x terms I'm going to highlight with yellow, and the term without any x's I'm going to highlight in green. Okay, when we look at this expansion over here, we notice that the x term has a coefficient of 12. That is what we can compare to this term. These terms I've highlighted in yellow, and the constant on the end we can compare to the negative 2a squared. These are both terms without any x's in them. This constant on the end allows us to find what a is. Okay, so this is what's called comparing coefficients, where we've got, you know, an expansion on both sides of the equal sign, and those coefficients must be equal in order for those expansions to be equal. So we can say then that negative 2a squared is equal to negative 72. Dividing by negative 2, we get a squared equal to 36. I meant to write 36. And this tells us a is equal to plus or minus 6. Okay, so that's how we're finding a. Well, we've got two possible solutions for a. How can we find the single solution for a? We need to use these terms in yellow, the x terms. So then we look at a squared take 4a. These are the coefficients of x. And these need to equal the coefficients of x on the right hand side of this equation. So these need to equal 12. Alright, so if we plug in 6 for a, we get 6 squared take 4 times 6. This is 36 take 24, which is indeed equal to 12. Okay, so that means plus 6 is the solution for a. We can try negative 6. So this is negative 6 squared take 4 times negative 6, which is 36 plus 24, which is not equal to 12. So a equals plus 6 there. That allows us to solve for b, because then we use the coefficients of the x squared terms to find b. So the coefficients of x squared are 2a take 2, which is equal to 2 times 6 take 2, which is 12 take 2, which is 10. So that's b. Okay, so final answer is a equal to 6 and b is equal to 10. Okay, so that's complicated question where it's not obvious what you need to do, but generally the approach would be expand brackets and compare coefficients. So compare coefficients is what we're doing here. All right, on to the last one. This says the minute hand of a clock is 8 centimeters long. The hour hand is 1.5 centimeters shorter. Calculate the distance between the tips of the hands at 8 o'clock. Okay, so let's go ahead and draw a clock. Do you remember learning how to read a clock? And you'd have like a sheet full of clock faces, and you'd have to write down the time underneath. I remember. Those were the days. Okay, so what do we have? Calculate the distance between the tips of the hands at 8 o'clock. So 8's over here. And where are the hands at 8 o'clock? The minute hand is pointing to 12. And the hour hand is pointing to 8. Okay. Alright, so we have this shape and we need to find the distance between the tips. So that will be this distance here. Okie doke. There's one other thing we need to think about in terms of the geometry of a clock. So we need to think about the degrees in a clock. How many degrees in a circle? 360. How many hours on a clock? 12. So the degrees between each hour is 360 divided by 12, which is 30. Doing some quick math there. And so if we go, well, we could count back from 12. That's 11, 10, 9, 8. That's 4. So this angle in here is going to be 4 times 30. 4 times 30 is 120. So we also need this angle in here. This is a tricky question because you need to kind of fill in all of the details on the diagram, on a diagram you draw, in order to figure out how to answer it. So what we're actually doing here is solving a triangle with an angle of 120 and sides of 8 centimeters. That's the minute hand, 8 centimeters, and the hour hand is 1.5 centimeters shorter, so 6.5 centimeters, and the angle in here is 120. And what we're looking for is this side over here. Let's call that A. Okay, so how do we find A? Well, it's not a right triangle, so we're not going to be using Pythagoras' theorem. We're not going to be using the trig ratios. Pretty much all we're left with then in GCSEs is either the sine rule or the cosine rule. And the sine rule is not going to help us here because we only have one angle, so we must have to use the cosine rule. So the cosine rule says a squared equals b squared plus c squared. Take 2bc cosine a. The little letters are the sides. So A is the side we're looking for. These are B and C. It doesn't matter which is which. And the big A is the angle. So once you realize this, once you draw your diagram and figure out what you need to find, all you need to do is plug in the numbers into the formula. Okay, so A squared is going to equal B squared, 8 squared plus 6.5 squared. Take 2 times 8 times 6.5 multiplied by cosine of 120. This is most likely a calculated question, so you could plug this straight into a calculator, although you do need to know the exact values for cosine of 120. I have a video on this, how to remember the exact values of the trig functions for GCSEs. You only need 2 triangles. So cosine of 20 is related to cosine of 60, which is a half. Cosine of 120 is negative a half. But you probably don't need that here. Again, just plug it into a calculator. Making sure your calculator is in degrees mode. You should get an answer of 158.25. And remember to take the square root because this is a squared. So we need to take the square root of that answer and we get 12.57 and so on. So A is equal to 12.5797 and so on. And then we could round that off. It doesn't say in the question what to round it off to, but let's say 12.58 centimeters. So there you go. They were 3, fairly difficult GCSE questions. I hope you found that useful. Again, if you have any more questions, feel free to email me, leave a comment, whatever, and I'll see you in the next one. Bye for now.